There's nothing quite as fascinating to watch as a gyroscope. And one of the best things about having your own home machine shop tools is that you can make this sort of thing yourself. Maybe as a gift or a demo piece, or simply for the fun of making it. So in this two-part video, I'm going to show you how to make this gyroscope from some commonly available metals using a benchtop lathe and mill. The design is based around a solid brass flywheel and it's mounted on a steel axle. The ends of the axle are pointed and run inside these cone bearings. And the height of the gyro can be modified using extension rods that pivot inside this base. You can download a set of free plans from makescene.com and be aware that I've dimensioned the drawings to suit the size of my lathe, but the basic design can be scaled to suit any lathe. The key thing to figure out is the diameter of stock that your 3-jaw chuck can handle using the outside jaws. In my case, I've sized the project to work well with a 4-inch chuck. If yours is different, then just scale the drawings accordingly. Okay, so to complete this project, you'll need these materials. Now you might already have the small rod sections you need for the project in your scrap drawer. If not, you should be able to track down what you need from the local hobby or hardware store. But you're probably wondering, where am I going to find the large stock? Well, this is where it really pays to get to know your local machine shops and fabricators. Talk to them, tell them what you're doing, and ask for their help. Most will have an off-cut rack full of the metals that they usually work with, and will be more than happy to let you find what you need. My local machine shop has this huge selection of steel, brass and bronze offcuts. It's an absolute treasure for a home shop machinist. So I've picked up this length of 3-inch diameter brass for a fraction of what it would have cost me elsewhere, as well as this piece of aluminium tubing from a local boat builder. And if you don't have a metal cutting bandsaw, while you're still there, see if you can get the machine shop to do the cutting for you. They're usually happy to do it for a small cutting fee, and it sure beats using a hacksaw. So with our stock prepared, let's get started. The first part we're going to make is the flywheel. Now the brass stock will have rough edges at this point from the saw cut, and we really need smooth surfaces for marking out, so it's going to need some facing cuts to clean it up. Using the outside jaws, secure the workpiece in the chuck and then face each side. As you face that second side, bring the workpiece to final thickness. Next up, we need to do some marking out. And to keep things simple, we're going to use a tailstock centre to form a centre mark. Push it into contact with the work and then give it a gentle tap with a soft hammer. We can now apply some layout fluid and then using a set of dividers, mark out the key dimensions. Okay, so this is the cutting tool we're going to use to form the recess in the flywheel. Its shape means we can use it to cut both left and right, and it's also got a lot of clearance on the front and sides so that it doesn't rub on the sides of the recess as we cut. Set the tool on centre and begin by removing the bulk of the metal in the recess. When you get close to depth, rotate the top slide of the lathe to 20 degrees and start forming the outside tapered shoulder, this time by feeding in with the top slide hand wheel. When you've reached the line, swing the top slide over the other side to 20 degrees and form the other taper. Okay, now we're going to form the hole for the axle, and we really do want this hole to be right on centre. So start out with a spotting drill and then follow with an undersized drill bit and finally a reamer. Now if you don't have a reamer, you can simply drill the hole to final size, but the fit on the axle may be just a little bit loose. That's one side complete. So remove the work and now load that off-cut of aluminium, because we're going to make one of my favourite shop accessories, a custom super glue arbor, and we're going to use it to hold the wheel for the next few operations. Face the stock and then form a short spigot on that front face. Make sure that the spigot is a close fit with the hole we just reamed in the flywheel. When the fit is good, form a few small grooves near the perimeter, apply a small amount of glue, and then using the centre spigot to locate the work, push it into place. Within a few seconds the glue sets and the work is now re-centred on the bore of the part. So now we have a very convenient way to access not only the front of the work but also the back and sides. This means we can now form all of the remaining surfaces and know that they'll be concentric. Off camera, I've turned up this simple centering button to locate the dividers for marking out the second side. Once that's complete, we can do the same grooving operation as the first side. Set up the top slide for a 45-degree chamfer cut of each edge, and once that's complete, the bulk of the hard work for the wheel is done. Now, using a little heat from a propane torch, break the super glue bond. You can use acetone to wash off the glue residue. Next, we're going to set the work up on the mill to make the hole pattern, and ideally we'd locate the work using a dial test indicator, but if you don't have one, here's a workaround that'll get us pretty close. Turn a 60-degree point on a piece of steel, load it in the chuck, and using the quill gently push it down on the central hole. If you leave the work free to move, it'll slide onto the point and find its own position directly underneath the spindle. While it's being held in place, you can clamp it down. Reset the hand wheels or the digital readout if you have one, and you've very quickly found the centre of your workpiece. Now, it's not perfect, but it's certainly close enough for what we're doing with this project. I'm going to use this end mill for the final hole size, but since the metal is not very thick where we're cutting, I'm using a spotting drill to remove most of the metal first. And I've got the coordinates nearby to help me avoid making any mistakes. A 4-hole pattern is certainly the easiest to make, but if you're comfortable dealing with the hand wheel backlash or you have a digital readout, then I think the 6-hole pattern is the way to go. The end mill will push up a small burr on the outside of the holes, so use a countersink or a deburring tool to knock those off. And we're done. In the next video, we'll make the axle, frame and bearings and put the whole thing together for a run. I'm Chris from ClickSpring. Thanks for watching. I'll catch you on part 2.
If you liked this video, subscribe to our channel or send us a comment on Facebook or Twitter. Be sure to check out our other project videos or visit us on MakeZine.com.